The Skyline Tower in Niagara Falls is about 160 meters high. From a certain distance, Frankie measures the angle of elevation to the top of the tower to be 65 degrees. Okay, we can see that right here. He then walks another 20 meters away, a little farther, from the tower in the same direction and measures the angle of elevation again. We'll call that angle A. Use primary trig ratios to determine the measure of the new angle of elevation. So we're basically trying to find the measure of angle A. Alright, since I see that triangle CBD already has two angles, a 90-degree angle and a 65-degree angle, and a height of 160 meters, I'm going to start with that. So I'm going to just find the distance from B to D. Now, it's not really that convenient to call that side BD, so I'm just going to call it, I'm going to just invite my own letter. Let's say J for that. Alright, so we can do sine of 65 degrees, which would be equal to 160, which is the opposite, over the hypotenuse, which we don't know. That would help us find the hypotenuse. We could also do cos of 65 degrees, which is adjacent. Oh, that's letter J here that we want. That's good. Over a hypotenuse, but we don't know the hypotenuse. Ooh, that's two variables. That won't be very helpful unless we find J or the hypotenuse first. And we have tan of 65 degrees, which is equal to 160, which is the opposite, over adjacent J. Looks like this is a winner. I have one variable, which is good, and it's the variable I'm looking to get. That's how you know whether to use sine, cosine, or tangent. The one that gives you one variable, and it's the variable that you're looking to get. All right, so right here we see we have something equals something over something. So there are no pluses, no minuses. So what I like to show everyone here is let's just keep these things kind of even. So you have tan of 65 degrees. Let's put it tan 65 degrees over 1. It's just nicer to look at. That way the left side has a top and bottom. The right side has a top and bottom. Then if we ever have to flip them around, the left side, if I were to flip this tan of 65 to the bottom, I need something to go on the top. And sure enough, in this situation, if you see the letter J is on the bottom. Now, we don't want to know what 1 over J equals. We want to know what J equals, right? So it's perfectly fine. If you have a situation, there are no additions, no subtractions. It's just multiply and divide, right? You just have basically something over something equals something over something. You can literally just flip both of these sides, and the equation will still remain true, okay? So you got a new equation now. It's going to be 1 over tan of 65 degrees equals J over 160. Now, I wouldn't want to do that every time. I only want to do it if the variable is on the bottom. Now, we're very happy because we have the variable on the top. Now, the number underneath the J, we can cross out because we're going to multiply both sides by 160. And that goes on this side because we have to multiply the left by 160. And J is simply equal to 160 times 1 divided by tan of 65. As you get better at this, you'll realize that you don't actually have to write times 1. You can just do 160 divided by tan of 65. Now, I prefer that you do this all in one step. Like, some people would be tempted to say, like, this is equal to 160 divided by, and then they would change tan of 65. Let's see what that would be, 65, to 2.145, and but that's rounded. So number one, you just did extra work. Number two, you have a rounded number, so your answer is not going to be as good, right? Don't do that. Just straight up do 160 divided by tan of 65 degrees equals, and you get 74.61 is equal to J approximately, right? Don't put equals exactly because it's only approximate. All right, now that we know J, so now we know the distance from A to D, which is just 20 plus 74.61, which is 94.61. All right, so again, we can now say sine of A, we don't know that angle, is equal to opposite, so 160. We're looking at the bigger triangle now, this triangle right here. So sine of A equals opposite over hypotenuse. I still don't know the hypotenuse of that one either. So here I have the letter A as a variable, and right here the hypotenuse is a variable. Two things I don't know. We will not be using this equation. Let's go to cosine. Unless, of course, like later on, if I find A, then I can come back and use that equation to find the hypotenuse. Or if I find the hypotenuse, I could always come back and then find A. But we need an equation with only one variable in it if we want to be successful. So let's try cosine of A. I need a name for this whole side here. I don't want to call it AD, it's just too long for me. So let's call that K. All right, so cos of A, adjacent over hypotenuse, is K, 94.61, over H. We don't know A, we don't know H. That's two variables we don't know, so we can't use this equation either. So let's go to the third one. Tan of A is opposite, 160, over adjacent, K. I do know what K is. K is 94.61 approximately. Okay, now I have only one variable here. So you'll notice there are many teachers that'll make you decide whether you're going to use sine, cosine, or tangent before you start. I say just put them all down. Just write them all down. It doesn't matter. When you're looking at them, you'll see, oh, I'm going to use this one. The other two, it's not that they're incorrect. It's just that it doesn't help you very much. Right? So you can write it down, and that's not a problem. I just write all three down, I just start writing them down until I find one that's going to be helpful that only has one variable, and that's the variable that I'm looking for. Right? So here we got tan A equals 160 over 94.61. We only have one variable. It's the variable A. The problem is it's kind of attached to tan here, right? So how do we get rid of that? Well, we're going to have to find out what angle is this A value, so that when I say the tan of that angle, it's going to be equal to 160 over 94.61, which, by the way, is about 1.691. But I'm not going to write 1.691 because that's rounded. Why would I why would I go to an extra step to round it only to get, a worse answer? Because now that it's rounded, my answer is not going to be as good. Right, so I'm just going to keep the 160 over 94.61. If you want to round it, go ahead, but my answer will be better. Right, now I want to know what angle can I say the tan of to get that? Well, the best way to find that out is to do the tan inverse of that. Tan inverse says approximately, so A is going to be approximately equal to 59.40. So the angle of elevation is about 59 degrees, or you can say 59.4 degrees or 59.40 degrees, you decide. As long as it's useful. I wouldn't say, I would round it to something that's going to be useful for my situation. So it depends on your situation at hand. But here I'd say 59 degrees is fine. All right, let's move on to question number 9. A rescue helicopter is flying horizontally at an altitude of 1,500 feet over Georgian Bay towards Beausoleil Island. The angle of depression to the island is 9 degrees. How much farther must a helicopter fly before it is above the island? Give your answer to the nearest mile. All right, let's name these sides. We're going to name this distance D. That's the distance we're looking for. Let's call this side H, and we actually don't even really care about H, the hypotenuse here, because that's not what the question's asking. All right, let's start. Sine of 9 degrees is equal to opposite 1,500 over hypotenuse H. There's only one variable. That's good news. The problem is it's the variable H, the one we don't care about. So let's leave that aside for now. Let's try cosine. Cosine of 9 degrees is D over H, adjacent over hypotenuse. Two variables, that's not going to do us any good. So once again, we're going with tan. Tan of 9 degrees is 1,500 opposite over adjacent, which is D. One variable, awesome, and it's the variable we want. This is the equation we're going to use. All right, when you have an equation of this form, you guys know I like to put the tan 9 over 1 just to keep things even, have something on top and on bottom on both sides. Check to see if the variable's on top. If it's on top, we're good to go. If it's on the bottom, we want to do the flippity-floppity thing. That's the technical term for this math thing. We're going to flippity-flop it. So it becomes 1 over tan 9, which is equal to D over 1,500. And the D is what we want. This 1,500 is no good there. So just like I showed you before, get rid of that 1,500, goes up to the top here, and we have 1,500 times 1, which is kind of useless, divided by tan of 9. That will be equal to D. All right, my trusty calculator comes out with the answer 9,470.6. Therefore, before the helicopter is above the island, it must fly an additional 9,470.6 feet. But wait, we want to give our answer to the nearest mile. So we're going to have to convert feet to miles. So if you remember in the video that we have about converting in the imperial system, we know that there are 3 feet per yard, and we know that there are 1,760 yards per mile. So to go from the number of feet to the number of miles, we're going to have to divide by 3 to get to yards, and then we're going to have to divide by 1,760. So we got 9,470.6 divided by 3, so now we have 3,156.9 yards, and we're going to divide that by 1,760 to get 1.794 miles. But if we want to round it to the nearest mile, it's up approximately, well, it's not approximately, it's 2 miles to the nearest mile. So we'll just replace the 9,470.6 feet with 2 miles, and we have our answer. Therefore, before the helicopter is above the island, it must fly an additional 2 miles. All right, let's move on to question number 16. 2 boats F and G sail to the harbor H. Boat F sails 3.2 kilometers on a bearing of 176 degrees. Boat G sails 2.5 kilometers on a bearing of 145 degrees. Determine the distance from each boat straight to the shore. All right, this looks simple enough. We just have 2 triangles here. We know this side. Let's just focus on the left triangle, GDH. We know this side right here is 2.5. We know this angle. Well, here, this angle here is 145 degrees. So this angle here must be 180 minus 145 degrees, because we have a straight line here. 180 minus 145 looks like 35 degrees. And so we just have a triangle here. We could use sine, cos, or tan. Sine will be opposite over hypotenuse. This side here we don't really care about. Hypotenuse we know, so we could easily get this side, but that's not what we're looking for. Cosine of 35 will be adjacent over hypotenuse. This side here is what we're looking for, and so that's good news. And hypotenuse, we know it, so we have one variable, and it's the variable we want. Let's stop there. We're going to use cosine. All right, you guys know that when I have this type of equation, I like to put the cosine 35 over 1, so we have top and bottom on both sides. Look for the variable to see if we have to do the flippity-floppity move. The variable is on top. That's good news. No flippity-floppity necessary. So the d is already on top. Underneath, we have our 2.5, and so we just move that over to this side here. So here we just have cos of 35 degrees times 2.5 divided by 1, which is unnecessary. It won't change the answer. And that is approximately 2.048. Therefore, the distance from this boat to the shore is about 2.048 kilometers. Let's do the other one now. This angle here is 180 degrees minus 176 degrees, 4 degrees. We know we're going to have to use cosine again, so cos of 4 degrees is equal to adjacent, that's this distance here, divided by the hypotenuse, 3.2. I like to put this over 1, and once again we have the variable on top, so we don't have to flip it. We take what's under the variable, we're going to move it over to this side, and so we have 3.2 times the cosine of 4 degrees. That's equal to approximately 3.192. Therefore, the distance from this boat to the shore is approximately 3.192 kilometers.